Today's lesson is on calculating percent composition or percent by mass. You'll see it called both things in a textbook and in particular problems. Sometimes also called elemental percent composition. So basically what we're going to be doing is taking a look at things from an analytical chemist side. And basically what they do is they analyze what's in a particular substance. And that's what we're going to be doing today. Next week we'll actually reverse that process and learn how scientists are able to figure out chemical formulas for things that they only know how much of each element is in there. So unknown substances, very common process. So percent composition, here's what it is. If we know the formula of a compound, we can find its chemical composition. And we can express that chemical composition as the mass percent of each element in the compound, or again, percent by mass. So again, the elemental percent composition. So to find the mass percent of a particular element, we are going to take the part of the compound that is a particular element, and we're going to divide it by the mass of the whole thing. So again, when you think about percentage, 30% off, it's 30 out of the full price. Okay, so what is the part out of the whole? So it works the same way for chemical substances. Each part is the individual element that is in that compound, multiplied, of course, by however many times that element appears in there. So we're going to take a look at some examples. So just keep this in mind. Mass percent, mass, of course, meaning grams, so the part divided by the whole thing. So here's an example. Carbon dioxide, common everyday substance. We have one carbon atom in our chemical formula. So we know that if we look on the periodic table, we're going to see the mass is 12.01. We can call that AMUs if we're talking about individual atoms, or we can call it grams if we're talking about a whole mole of atoms. Remember that number on the periodic table is the number of grams for a whole mole of atoms, or AMUs for one atom. So it doesn't matter which way we're using that, just watch your label. We are most commonly going to use grams because that's something that we can work with in the laboratory. Our other element, of course, is oxygen, and there are two oxygen atoms in the formula carbon dioxide. So we're going to take 2 times 16 and again replace with one of the labels at the end, AMUs or grams. So now we're going to take that information. This is the same thing that we used when we were finding the molar mass, and essentially we are going to be doing that again in these problems, but what we really want to do is break it down into individual parts. You need to have the mass of each individual type of element separate, and then the mass of the whole thing, because again we're doing part out of the whole thing. So to find the percent of carbon in carbon dioxide, we take the atomic weight, we're calling it atomic weight because it's just an atom, all right, of carbon, which is 12.01 grams, and then the molecular weight, molar mass, any of those things again mean the same thing, of the whole thing. So our part is carbon dioxide, our part is carbon. Carbon dioxide is the whole thing. So it's 12.01 grams for just the carbon. The mass of the whole thing, if we add everything all together, is 44.01 grams. So we multiply by 100 at the end to make it into a percentage. We're going to do the same thing with oxygen. Our part is oxygen. So we have 2 oxygens. That's where we get the 32 grams from. And we have, again, the full molar mass of the whole compound is 44.01 grams. Again, multiplied by 100. So now we know that carbon dioxide is 27.29% carbon and 72.71% oxygen. Since there are only 2 elements, it's a natural check. If we would add these 2 things together, they should equal 100. No matter how many elements you have, your percentages should always equal 100, or else you have a mathematical error. So at this point I want you to pause the recording and try this compound down on the bottom on your own. Keep in mind that there are 2 manganese. The 3 on the outside then goes with everything, so there are 3 carbons, and 3 times 3, or 9 oxygens. So again, we want to find the mass of the 2 manganese, the mass of the 3 carbons, the mass of the 9 oxygens separately, and then divide each one of those by the mass of the whole thing. So take each part divided by the mass of the whole. So again, pause, take a moment to do that. The next slide has the answers. Okay, so let's take a look at what we did. Manganese has a molar mass of 54.94. There's 2. So our total mass for the manganese in this compound is 109.88. Again, carbon, 12.01 times 3 gives us 36.03 for the total mass of all the carbons in this compound. There are 9 oxygens, so 16 times 9, 144 grams is the total mass of all the oxygens. So we add all of that up, and that is our molar mass of the whole compound. Same thing we've been used to doing already with our mole calculations. The only new part is now we're going to take each individual piece and we are going to divide it by the whole thing. So we take the part that's just the manganese, divide by the whole thing, times 100, and there's our percent of manganese. Take the part that's carbon, divide by the whole thing, multiply by 100, here's our percent, that's just carbon. Same thing with oxygen, take the grams, that's oxygen only, divide by the whole thing, times 100, gives us a percent of oxygen. So again, the part divided by the whole for each individual piece. So we have 3 elements, we have 3 percentages. If we add them all up again, we should have 100. So it's a natural way to check your answers. So now you're going to practice on your own. The problems here are number 67 and 70. You can either work out of the textbook or you can work right directly off of this slide. Same thing. So we have 3 compounds. You have to find the percent of each element in each compound. And that's for 67. Same idea for number 70. So you're just going to work your way through. Once you're finished with that homework, if you have any other old homework, you should be working on that. If you are finished with all of your old homework and today's homework, then please work on finishing your lab. It's due on Monday. Excuse my typing there. I have tomorrow, but it is due on Monday. If you are finished with all of that, your lab included, then you can work on your mole poster. Tag board for the posters is located on the counter on the left side of the room. The next slide has a very quick overview as a reminder of the lab and what needs to be in there. So we talked about this yesterday. So please make sure you review this information, double check your sig figs on the lab itself, your calculations, and in your final answers. Again, the lab is due Monday at the beginning of the hour. You do have to write a conclusion, and then don't forget also to do the self-analysis. Last but not least, there's a quick little cartoon here at the end that pretty well goes through what an analytical chemist is all about. Again, we talked analytical chemists analyze what's in stuff. So here is an analytical chemist as a book reviewer. I think I can truly say that in this book we have all of the elements of a first-class thriller. Carbon, aluminum, silicon, oxygen, nitrogen, sulfur. Get it? Elements. The elements of a first-class thriller. They're all the good parts and things that make a great book. All right, you guys have a great weekend. Please use your time wisely. Everybody should be working on their own. If you have a quick question for your lab partner, that's okay, but otherwise you should be able to get your work done today on your own. Have a great weekend, and I'll see you on Monday.